So first we got to find the composite function, and then we're going to state the domain. So for A, f of g, f composite g, would be here's f of x. So f of g of x. You're going to take f of x and replace the x with this. So square root of x minus 2 squared plus 3. All right, and the square root and the square, they cancel. This just becomes x minus 2 plus 3. And this is going to equal x plus 1. All right, so then the question is, what would the domain be? Well, since we're plugging in g of x, if we look here, x cannot be anything less than 2. If x is less than 2, this is the square root of a negative number. So we would definitely need x to be greater than or equal to 2. So my domain would be 2 to infinity. For part B, we're doing it the other way. G of f of x. So we take g, which is the square root, x minus 2, replace x with x squared plus 3. So that is that one. Um, and then minus 2. All right, so I basically replaced this x with f of x. So that x became x squared plus 3 minus 2. We can simplify that. That's square root of x squared plus 1. And that would be my composite function. And then as far as the domain, uh, basically, no matter what I plug in here for x, it's going to be a positive number, and I can take the square root of a positive. If I look at f of x, there's no restrictions there either. So my domain is going to be negative infinity, positive infinity. All right, for C, f of x, we take f of x and replace the x with f of x. So instead of x squared plus 3, like this would be x squared plus 3, but the x gets replaced by x squared plus 3. And then here's where we're going to have to do some foiling here. This is going to be x squared plus 3 times x squared plus 3. And that's going to be x to the fourth. 3x squared and 3x squared is 6x squared. And 3 times 3 is 9. And then plus 3. So this one becomes x to the fourth plus 6x squared plus 12. And there's no restriction on this. Any number will work, and there's no restriction on the f of x. So my domain would be all real numbers. All right, and then last but not least, g of x. If I look at that, g of x is the square root of x minus 2. And I'm plugging in g of x for x. So I'm also plugging in the square root of x minus 2. So the square root of x minus 2, all under the square root. That would be my g of x would equal that. All right, and then for the domain here, we can't have um, this part be negative. So if this was negative, that'd be a problem. And so, if we have a 2, anything, kind of like this one, if we have anything 2 or greater, then this part um, would become negative, and you'd have the square root of a negative number. And then we also have this thing to keep in mind. So even if this was, for example, if this was 3, you'd have 3 minus 2. That would still be 1, and 1 minus 2 would still be negative. So basically, what you want to think of is this piece here the square root of x minus 2, that piece has to be greater than or equal to 2. Because if this part's 2, 2 minus 2 is fine. If whole thing is 3, you're still okay. But whatever this thing is, it has to be at least 2, or else when you subtract 2 from it, you'll get a negative. All right, so now we have this kind of little mini equation to solve. So I can square both sides. X minus 2 has to be greater than or equal to 4. X has to be greater than or equal to 6. So as long as X is 6 or bigger, this will be 2 or bigger, which means this will be positive. So a little tricky on the domain there. But the domain for this one would be 6 to infinity.